Hello everyone. So in this video we are going to talk about the performance of linked list operation. So you can say we are interested to do the complexity analysis. So if you are going to use linked list in your application, then what will be your running cost? So when we work with the linked list, there are three fundamental operations that we are doing most of the time. We are either interested to search any node or any value. You may be inserting any node or you may be deleting. So in general, when we say the cost of such operation in the linked list, it is big O of n. And about the insertion, it is a constant operation, and about deletion, it's a constant operation. So in general, when we talk about the insertion and deletion, they are like constant operation, and the search is a big O of n cost operation, where n is the number of nodes in the linked list, or you can say the size of the linked list. Now, we have seen that when we talk about the different formats of linked list, like single linked list, double linked list, circular linked list, and when we studied about the insertion operation, we have considered the different cases, like adding in the first node, the last node, and between the position of the first and last node. So let us go into deep that how the performance will vary, or what is the cost of the operation if we are taking the specific operation on these linked lists. Let us first take the single linked list. Already we have discussed in detail what is single linked list, how it is composed of, how we can implement the single linked list by using a program. So all the logic we have discussed in detail in our previous lectures, in the previous videos. I have explained everything. Now let us talk about the time complexity. So in the single linked list, if you are interested to search anything, it will be big O of n. Let us take these cases which we have discussed in detail. So we take the three cases, that is at the beginning, at the last, and somewhere in between. So if you are going to insert any node in the linked list at the beginning, then you need to only set the head pointer, and also you need to connect the first node to the second node. So this is a constant operation, and this is obviously big O of 1. So big O of 1 represents the constant effort. So if you are inserting a node in the beginning, it is obviously a big O of 1 operation. But if you want to insert a node at the last, then the cost will be big O of n, because you need to traverse through all the nodes, because this is not a random access. Linked list is a sequential access. So in order to move to the last node, you need to go through all the previous nodes. So if a newly created node is going to be inserted at last, that means you have to go up to the last node. So in that case, if I say inserting a node at the last, then it will be big O of n cost. Similarly, if you are inserting in between, so when we talk about the big O notation, we actually refer to the asymptotic notation, and in asymptotic notation, we simply look to the behavior, or we want to classify that to which class it belongs. Between actually depends on the position, and position will depend on some criteria. So you have to satisfy that criteria, and you have to do some iteration based on the given criteria. Means you are not doing the constant number of operation as we are doing the inserting of node at the beginning. So if you want to insert somewhere in between, then again you will be doing n by 2 iteration, and n by 2 belongs to class n, and it will be again big O of n. Now if we look to the deletion operation, in the deletion, if you want to delete the first node, then we are independent, or we don't bother about the size of the linked list. We don't care for how many nodes are there in the linked list, and the cost will be constant and big O of 1. If you want to delete the last node, in that case the size matters, and you need to iterate all the nodes to reach the last node, and again the cost will be big O of n. Similarly, like we have discussed in the case of insertion, in between also it will belongs to the class n, so notation will be big O of n. Now what is the meaning when I say big O of 1 insertion and big O of 1 deletion? Actually, if you look to the array, in the array what is happening, if you are maintaining an array and if you delete one element, then you have to shift all the other element to fill that vacant space. But in the linked list, this is not happening. What does it mean? It means if I have an array, so I have having element 2, 3, 4, 5, 6, 7. Let's say this is the element which I am having in my array. So I can say my first element is 2, my second element is 3, this is my third element, fourth element. Now if I remove this element, then this element must be the third element. Now in order to take this a third element, you need to shift this element 5 in this position here. Similarly, you have to shift all these, you have to shift all these successive elements one position prior to keep the order intact. Now this is your third element. So that's why when you are deleting something, similarly if you want to insert something in between, you need to make a space, and to make a space you have to shift all the element one position. So that's why in case of array, the insertion and deletion operations are actually the big O of n cost. But in the case of linked list, so if I am having the same scenario, if I am having a list something like this, 2, 3, 4, 5, 6, 7, this is the element I am keeping here, 2, 3, 4, 5, 6, 7, and this is all connected. Now this is my first element, second element, third element, and so on. Now if I want to delete this element, then there is no need to shift all element one position before to maintain this proper order. What will happen? We simply remove this node and connect this node to this node, then this will automatically become the second node. So this will require the constant effort. You need to simply just set some pointers and you are able to achieve your task. So in this context, we are saying that the insertion is always a constant operation, deletion is also constant operation. But if you look in this scenario, when you are actually inserting the node in the single linked list, or you are deleting a node in a single linked list, then you need to do this much effort. Now let us take about the W linked list. In the W linked list, if you want to search anything, obviously it is big O of n. Again, if we make the three criteria, beginning, last, and between, so what you will find that if you are inserting at the beginning, then obviously you are not bothering about the size of the list. You don't care for how many nodes are there, and it will be big O of 1. If you are inserting at the last, then it is again big O of n, and average also big O of n. If you talk about the deletion, so whatever the case arises in a single linked list, it will be the same in the double linked list. So you can find that the order will be, or the cost will be, or the complexity will be the same, big O of 1, big O of n, big O of n for beginning, last, and between. Now let us see what will happen in the case of circular linked list. So again we have a scenario where we want to insert in the beginning, we want to insert at the last, and insert somewhere in between. So if you want to insert at the beginning, then what will happen? In this case, the circular linked list, your insertion will also be a big O of n cost. Why? Because whenever you are inserting a node at the beginning, you need to go to the last node to update its value. So the cost will be big O of n, because the last node is going to connect to the first node. So you need to go to the last node to update its pointer so that it can connect to the newly created node. Fine. Similarly, if you are inserting at the last, then also you have to traverse all the nodes, reach to the last node, and then it will take big O of n, and for between also big O of n. In case of deletion, the same principle will apply. If you want to delete the first node, then the first node is actually maintained by the last node also, means the last node is also keeping the address of the first node. So when you delete this node, that means you need to update the last node as well, so that the last node will now point to the second node to make this operation possible. So again it will be big O of n. So just keep in mind that how the efforts will be required in the different scenario. So these are the performance of all these three different format of linked list, and These are the effort required. So these results will be used when you are going to evaluate the performance of your application, which is based on the linked list. So this is all for this lecture. Okay, thank you very much. See you in the next lecture. Take care.